Hello and welcome to the 20th MERLIN webinar. I think, Jan, we can start now. There are a few in the waiting room, but they are about to join. So I think you can start with the introduction.
Thank you, Astrid. Good afternoon, good morning for people all around the world. Welcome to the March webinar for the MERLIN European Union Research Project. Today we are fortunate to have somebody who will report from the very frontier of research, since he's just finishing up his doctoral work. Christian Schürings from the Department of Aquatic Ecology, Faculty of Biology at the University of Duisburg-Essen. And the subject today will be on the effect of agriculture on aquatic ecosystems. My job is to moderate the discussion. Please feel free to put any questions you have in the chat. I will record them and I will try to call you all in the order you raised your questions. At any time you can put a question into the chat, even during the question session. So Christian, the format today, we roughly go for about half an hour of presentation. Gives a soft boundary, so you can go over. Please, and after that, we'll take questions as long as time allows. So Christian, thank you so much for being with us. The floor is yours.
Hello, thank you very much for the kind introduction. Yeah, as I just said, I'm in the last week of my PhD and Sebastian Birk asked me to speak a bit about it. So I would just share my screen to start. So the theme of today is how agriculture affects river ecology. And it is based on studies I did together with Sebastian Birk, Christian Feld, Willem Kaiser, Jochem Keil, Nele Markert, and Daniel Herring. Like all of us know, freshwaters worldwide are strongly impaired. On the right-hand side, you can see a map of Limit Al in 2022, where it's shown the ecological status of rivers in 2015. And we can see that only about half of the rivers are in good status. Looking at Germany in particular, which is in the middle, you can see it's only about 10% in good status. And one reason for this is always considered agriculture. It exerts a multitude of different stressors and thus is often related to bad status in those rivers. However, those stressors, agricultural stressors, can also originate from other causes, including transverse structures or urban areas, such as for the mine in Frankfurt. Also, different organism types, macroinvertebrates, diatoms, and macrophytes, react or respond differently to the agricultural stress. There's influence of different ecoregions, river types, or soil types on those effects. And lastly, and in my opinion, maybe even most importantly, there's not just agriculture, but there are different types, starting from grassland to different crop types. In a recent meta-analysis we did like 2 years ago, we tried to find out what does literature say about the effects of agriculture on river biota. And what we could find is that there's a clear negative effect of agriculture, which is differing among continents and differing among different types of agriculture. We can see the strongest effect in Northern America, which is known for the highest intensity of agriculture, followed by Europe and Oceania, and could find that normally arable land or cropland has a stronger effect compared to grassland or livestock here. You could also see that there are differences in the response of organisms. We could show that the strongest effects are found by invertebrates, and rather smaller effects have been observed for diatoms, for instance, or fish or macrophytes. And what we could also find is the strongest difference between the type or the sensitivity of the different taxa regarding the response to agriculture. We could see that sensitive taxa, such as Ephemeroptera, Lecoptera, are strongly impaired by agriculture, while tolerant taxa, such as the invertebrates, chironomids, or oligochaetes, may even benefit. And we could also find in this meta-analysis that there's a difference between the metric you assess when you use some kind of quality metrics, such as average robot taxa or the ecological quality ratio or something like this, you find a strong relation to agriculture, -1. But if you use sheer richness matrices, richness, abundance, or something like evenness, you don't see a strong effect. So based on this analysis, we could see that there's differences between agricultural types and intensities in the effect of agriculture on river biota, but in general, we see a strong negative effect. So based on this analysis, we then thought, okay, let's do some larger scale analyses, do some analyses at the German-wide and even European-wide scale. And what we wanted to do is to investigate how different types of agriculture, such as rape farming, maize farming, potato farming, or grassland, exert different agricultural stressors, including fine sediments, nutrients, pesticides, or morphological alterations, and then has effects on the different freshwater organisms, microinvertebrates, macrophytes, diatoms, and fish. Question we asked us now is, what have been done until now in these kind of larger scale areas? Until now, most studies conducted were done with very coarse resolutions, such as 100 meters, and studies mainly discriminated between grassland and cropland. However, small-scale studies showed there are clear differences between the effects, and they normally are based on different spatial configurations or different types or intensities of agriculture. Just to give you a short outline, I would like to first talk a bit about the German scale and then give you some input on the European scale. At the German-wide scale, we were lucky that in 2022, Blickensdorfer et al. Working Group Fattig-Hostert published German-wide high-resolution land use data with about 23 different crop types at a resolution of 10 meters, available for the year 2017, now also for later years. And additionally to this land use maps, we used the German-wide Water Framework Directive sampling sites, about 10,000 of them, with about 7,500 sampling sites for macroinvertebrates and about 3,000 sites for macrophytes and diatoms. For each of these sites, we then calculated the ecological status and delineated the drainage basin, so the area to this area, the catchment, using digital elevation models. And then for each of those catchments, calculated or quantified the percentage of the agricultural land use of the different types, meaning, for instance, 20% grassland, 40% forests, 20% urban, and 20% potato or something like this. In our first study, which is now published in Science of the Total Environment, we then set up generalized linear mixed models and used the ecological status as a response, and the different land use types, we grouped them now into 8 groups as predictors: grassland, forests, extensive cereals, oilseeds, urban areas, intensive cereals, maize, vegetables, and permanent crops. Additionally, we used a couple of random factors to account for influences not originating from agriculture, such as different river types, the federal states, the year of sampling, and so on. And then kind of plotted the effect or the regression coefficients of the different land use types. We can see on the left-hand side now for macroinvertebrates, on the y-axis, the different crop types, and on the x-axis, we see an effect size. Negative means there's a negative effect, positive means there is positive effect, allegedly, at least in comparison to the other ones. And what we could find is that forests does have a positive effect on river biota or macroinvertebrates, while urban areas has like a small negative effect. We found the strongest effects for permanent crops and vegetables, and smaller effects for maize, intensive cereals, and oilseeds. Looking at these different crop types in more detail, we can see that permanent crops and vegetables are generally known for high pesticide input, while maize, intensive cereals, and oilseeds are rather known for high nutrient input, but rather smaller amounts of pesticides applied. Looking at macrophytes, we saw a pretty similar picture with the same patterns, though the effect sizes were smaller in general. But when we look at diatoms, we saw a totally different picture. We see the same pattern for forest and urban areas. Those pesticide-intensive crop types, permanent crops and vegetables didn't show any effects, and the strongest effects were found for maize, intensive cereals, and oilseeds. Other than before, for macroinvertebrates and macrophytes, grassland now showed a negative effect, likely because of manure applied on those grasslands. But I mean, until now, that's basically not so much evidence, it's just speculation to some extent. So we asked ourselves the question if there's evidence for these kind of relations between the land use and pollution. And for this, in a study led by Nele and me, we investigated for North Westphalia how the Water Framework Directive micropollutant monitoring is related to the catchment land use. And what we could find is that for urban areas, I mean, on the right-hand side, you can see a plot where in red you can see industrial chemicals, in green pesticides, and in blue pharmaceuticals. And we could show that for urban areas, industrial chemicals and pharmaceuticals are strongly related with these urban areas. And for cropland, pesticides appear more important, while for forests, we see kind of negative effects. Looking at different types of different macropollutants, we can, on the left-hand side, see it for urban land use, on the right-hand side for cropland. And we can see that for urban land use, industrial chemicals and pharmaceuticals have a clear positive relation, meaning there's a positive relation between the percentage or the concentration of those different chemicals and the percentage of urban area in the catchment. While for cropland, we didn't see so strong effects, though some effects of different pesticides. Now, looking a little bit more crop type specific, looking at permanent crops and vegetables I spoke before, we can see that there are much stronger effects of particular different pesticides. So we can see effect sizes of R square of up to 46 for thiacloprid with permanent crops, and of similar range for several pesticides with vegetables. Given this evidence, we then asked ourselves the question whether incorporating this knowledge of cultivation intensity can increase the correlation between agriculture and the ecological status. For this, we did some more kind of data processing, a study which is now published in Agriculture, Ecosystems and the Environment. And we grouped all different agriculture types from the study we used before to one group, agriculture, which has been done in most older studies. We also grouped all of them together except for grassland and called it cropland. And then it comes to those two steps which are kind of novel. We first created some kind of a pesticide index where we weighted those different crop types based on typical pesticide application rates. And did the same for phosphorus and nitrogen index using the Capri model with nutrient application rates. Given this, we now have 5 different kind of predictors of agriculture, cropland on those 3 different indices. In order to now compare it, we wanted to search for the most important of those indices and did this stream type specific. On the right-hand side, you can see in the upper part of the table macroinvertebrates, in the middle macrophytes, and the bottom diatoms. And on the y-axis, you can see always the pesticide index, nitrogen index, and phosphorus index. And for the different river types, we can see that for macroinvertebrates, pesticide index is most important for all river types. Macrophytes, it's mainly important except for the alpine region. And for the diatoms, we see the strongest relative importance for the phosphorus index. So for the subsequent analyses, we always use the most important of those indices for each particular river type and each organism type. We set up generalized linear mixed models again with bootstrapping, meaning we use 70% of the data and predicted them on the remaining 31. And used the ecological status as response and the different agricultural measures as predictors, meaning agriculture, cropland, or one of the intensity indices, and used several random factors, the ones we used before, including river type, federal states, and so on. This brings me off to the results of this study. You can see on the y-axis the R square. On the x-axis, you can see the different stream types. In red, you can see the agriculture, green cropland, and in blue, the intensity index. And even though those three indices are strongly correlated of Spearman up to 95, we see at least some differences. And we can see that the intensity index generally has the highest correlation or the highest relation. We see that, for instance, in particularly small mountain streams for macroinvertebrates, we see the strongest effect of agriculture up to an R-square of 43. And we can see that the differences between the different indices is the strongest for diatoms, particularly for small mountain streams. I would like to kind of stop here with the German-wide scale and continue with the European one, a study which recently came out in Water Research. And what we did was we used a little similar approach. We used about 50,000 subcatchments for which we had information on production intensity and modeled freshwater stress for nutrients, pesticides, hydromorphology, and water abstraction. And then using information from other studies such as Lebers et al., published in 2018, we delineated 20 areas of farming-driven freshwater impacts based on different or similarities in soil and geography, in agricultural practices, and in biomass output. For those 4 different freshwater stress types, we then plotted the kind of agricultural pressure in Europe. On the left-hand side, we can now see the pesticide pressure, which is particularly predominant in Western Europe and the Mediterranean. On the right-hand side, we can see the nitrogen pressure, mainly predominant in Western Europe. Now, in those 2 figures on the left-hand side, we can see the hydromorphological stressor, which doesn't have such a clear pattern. It appears more important in Eastern Europe compared to the other stresses. And the last one is a water abstraction stressor, which appears mainly important in Southern Europe in the Mediterranean. Using those 4 stressors, we then created an agricultural typology, an agricultural pressure index with all 4 pressures combined, which is one of the outputs of this study. And we can see that the strongest negative effects of agriculture are mainly located in Western Europe, Germany, France, Netherlands, as well as in parts of the Mediterranean. We also wanted to kind of investigate whether this information which we gained here can improve the prediction of the ecological status, and thus compared the agricultural pressure index with sheer agriculture in relation with the ecological status, and did this for different river types shown on the y-axis. And on the x-axis, we see the correlation coefficient. What we can see is that for all river types, the intensity index in blue has a stronger correlation compared to using sheer agriculture. And for all types combined, it is nearly twice as high. This means that quite likely this typology at least has some information and provides some information that it's worthwhile using different pressure intensities, and we could show that there's differences in the intensity. With this, I would like to give you a couple of take-home messages before we can start with the discussion. What we could show is that agriculture clearly impairs river biota. We could also show that the effect of agriculture strongly differs between different types of agriculture. We found that microinvertebrates were most sensitive to pesticides, while diatoms were more sensitive to nutrients. And we could show that accounting for the intensity of agriculture can increase the correlative strengths. We could show this for the German-wide scale and also for the European one. This I would like to finish with stating that, in my opinion, agricultural transition is urgently required to more sustainable practices. I would once again like to thank my co-authors, and I'm open for a discussion now. Thank you very much.
Thank you very much, Christian, for a very, very clear presentation. I believe you've set a record for clarity because not a single question has been entered yet. So while everyone gathers themselves, I'll take the liberty of asking a question as a wetlands ecologist and a landscape ecologist. You talk about the total area involved in cultivation, but one thing that's been shown with increased risk, say at the moment I'm doing research on wildfire risk, and is that spatial heterogeneity can influence the spread of fire, and we also know the spread of contagious insects. But that's a much more difficult thing to measure. The pattern. In the United States, we try to get farmers on the edges of rivers to at least on the margin of the river allow natural vegetation as a filter. So, has anyone looked at that, the spatial heterogeneity of and how that influences effects on river ecosystems?
Yes, I would like to answer it in kind of two ways. Maybe first regarding this heterogeneity. What we could find for the European study is that mosaic farming, meaning different types of landscape structures, has the lowest negative effect on those biota.
Mhm.
Meaning if you have those structures between different types of agriculture, some forests in between and so on, it is comparable to something like organic farming, which has rather small effects. It's one part of the answer. And the other part of the answer is that in our group, just the PhD student before me did investigations on the effect of riparian vegetation, and he could see a strong positive effect of riparian vegetation. Martin Palt was it. So kind of two-sided. We could see that kind of mosaic farming or farming of something like permaculture, something like this direction could have positive effects, or less bad effects. Let's say it like this. And on the other hand, that if you directly next to the riverside have some riparian vegetation of a couple meters, you can have clear positive effects. He could show that you can improve the ecological status by 1 to 2 categories by doing so.
Well, thank you very much. We do have a question now from Maria de Vries. She said, it is, for me, not clear if the pesticide stressor in the European study was measured as a general index or were more specific pesticides measured.
It is just a modeled information on potential toxic unit, I mean, response to the toxic stress of pesticides. It is the MS PUF, it says something to you, which is a board at a board resolution of like 200 square kilometers, I believe, and thus can only give some kind of overview, but no details.
Mhm. Well, in the absence of other questions, I'll jump in with yet another because that's the moderator's job. And we were quite alarmed by the results from Germany over the last 10 years, showing a very dramatic drop, not only in biodiversity, but perhaps almost more important in biomass of insects. And such that maybe a lot of ecological niches were not being filled, not just there weren't the species, the insects just weren't there. Um, Pesticides, of course, are highly implicated, but that's an ongoing debate. I guess the only measure you've looked at is with macroinvertebrates, right? Where we could, in other words, in an aquatic sphere, I'm just wondering if you're following that debate on terrestrial insects and how uh, we could make any link to aquatic insects on that level of the drop in biodiversity, drop in absolute biomass, and
Yeah,
connected with pesticides.
I do follow the debate, though I didn't research on it myself. There are different studies. I mean, Van Klink et al., I guess, 2020 even claimed that the abundance in rivers increased over time. I don't really know. But just to say this, I mean, but we could show that, I mean, macroinvertebrates include those different insects, ephemeropterans, trichopterans, and they are strongly impaired by pesticides. We did some preliminary analysis with EPT as a response and could see strong effects. And also those pesticide indices by the working groups of Lees et al. And Wolf Schäfer et al. Normally use some kind of indices where they could see that particularly the insects are strongly impaired by pesticides. And so I would definitely state that most likely also terrestrial, or at least the kind of dispersed insects now also have a negatively impaired by pesticides in the terrestrial realm. So I would definitely believe that the pesticides are quite likely also a reason for the terrestrial decline.
Mhm. Okay, great. Now, to improve the quality of questions, people are jumping in finally. Uh, so Wendy has sent a question saying, maybe I missed it, but what would be a reasonable distance that agriculture can still affect the water quality? In the Netherlands, we also have the problem with nitrogen deposition through air on land, which can transcend several kilometers.
So in theory, it can, or it can affect from the entire catchment. So the catchment can be huge, of several hundreds kilometers. So everything can affect the ecology of rivers. Though if we do have some kind of vegetation that is strongly hindered and strongly reduced in the amount which enters the rivers. So it's always differing depending on how are the kind of morphological structures in the riverside. And if you do have like huge riparian vegetation of maybe even 30 meters, you probably wouldn't expect high influences from several hundred meters away. So if you don't have anything and then there's a flush or rain event, then it's quite likely that there might be nutrients or pesticides even brought into the flushed into the rivers from several hundred meters away or even kilometers.
Thank you. Mary De Vries has a follow-up question. I also missed how the biota was measured, diversity, biomass, in the German study.
In the German study, we used this kind of ecological quality ratio, which is used to calculate the ecological status. So we did it separately for macroinvertebrates, macrophytes, and diatoms. And then there's some kind of a multimetric index, which was established, I think, about 20 years ago. And yeah, it's actually uses different, it's actually kind of a biodiversity related metric, which accounts for the habitat for different river types and so on. Does it answer your question, or do you need more information on this?
Yeah, Maria, does that answer your question?
Oh yeah. I can just use my thing. Yeah. Thanks, Christian.
All right.
Great. The next question is from Sebastian Birk. Given that such overview studies require a lot of modeled and thus rather imprecise data sets, what would be the immediate next steps for improving such analyses that you have done?
I mean, at the German-wide scale, we rarely used model data, but we used measured data. And if we were able to use European-wide data, which is measured rather than modeled, it would be the next step to do at the European scale. So I would go for finding a solution not to have to use the MS-PAF or this kind of pesticide modeling and the nutrient modeling, but rather try to use, I mean, from the different member states of the EU, directly measured information.
Okay, the next question is from Tom Stewart. He said, as with Wendy's question, how does your study differentiate between upper catchments and lower catchments and the accumulation of pollutants downstream?
We did account for spatial autocorrelation, which we could not find any strong effect from. So we didn't have the problem that we had like two different sampling sites which were downstream from each other. Though we did, but we also tried or checked for was using buffer regions, meaning 1,000 meter, 5,000 meter upstream, then buffering like 100 meter or something like this. Though the effects were generally stronger at the catchment scale, so we refrained from using the buffer zone then. But we did not distinguish between the upper catchment and the lower catchment, but just used kind of sub-catchments, the drainage basing, so every area which would flow to this particular area, at least for the German-wide scale. For the European scale, we use those functional elementary catchments, which are used by the EU.
Thank you. Okay, we have now from Joshua Reut of TNC. I love that you stratified impacts on major stream types, European-wide. And I suspect, a somewhat academic question, how easy or difficult it would be to stratify per type, per ecoregion, in a way to determine the reverse. Where are the best places to restore or protect streams that have the fewest impacts? For example, minimizing other impacts such as fragmentation in those areas that have the best chance of healthy systems and species persisting with climate change. I can imagine a gap analysis where we might identify agriculturally impacted stream types that really need more conservation actions because they are a rare type, particularly needy of restoration.
That's kind of a great idea. I totally agree. Though at the European scale, that won't be possible until now, I believe, because we are very coarse scale and we had a lot of assumptions we had to make. At the German-wide scale, that would be definitely possible. And as soon as we have better high-resolution data at the European scale, it would be also possible and would be definitely a nice next step to do.
Okay, thank you. And now a question from Eva Hernandez of the WWF. What data did you use for river quality in the study? I find some areas a bit surprising. For example, the Duero Basin is the basin in Spain with the best status analysis, especially hydromorphology. Would that be the cause why it appears red in the final map of impacts compared to other areas with more intensive farming?
I figure that you're referring to the European study, and looking back at this study, I believe you're referring to the left side here. So this is actually the percentage of agriculture in the potential floodplain area, meaning we assume that if there is more agriculture within the floodplain area in a particular region, that it has potentially altered or changed the morphology or the hydromorphology of those areas or those river types. It just increases the likelihood or the probability of having kind of modified stream types. So yes, if we have intense areas outside of those floodplains, they probably have a strong effect through pollution, which would be nutrients or pesticides in this regard. But if it's within those floodplains, it's more likely to have an effect on the morphology.
Thank you very much. Those of us who love the wine of Ribera del Duero were somewhat nervous about your answer, I can tell you that. Well, at the moment, I'm not seeing any more questions, and I'm looking around. I can't see any faces, so I think we've followed up. And so I want to now remind everybody that we will have a seminar on the 2nd of April, 2024. That's a Tuesday, not a Monday. The presenter will be Shane McGuinness, who is leading a sister project to MERLIN, the Waterlands Project on renaturalization of boglands, peatlands, and others in Ireland and other places. I can highly recommend Shane's top quality researcher, well worth the time. I believe that, so I want to thank you again, Christian, for a very clear presentation, and we all would wish you the best of luck in your defense, though it doesn't look like you need a lot of luck. Looks like you're doing great. So thanks again, and we look forward to seeing everybody in April.
Thank you.
Thanks, Christian, also from my side, and bye-bye, everyone.
Bye.
Bye-bye.